Hi everyone. Today we're going to start talking about groundwater, where we find groundwater, why we have groundwater, the importance of groundwater, how it moves, and how it affects our geology. So the outcomes for this lecture is to explain what is groundwater, where it is, what it's made of, and how it moves, how it flows. Then we'll talk about porosity and permeability, both very important when we're discussing groundwater. And we'll look at the difference between aquifers and aquatards, and different types of wells and springs, and then how groundwater can be depleted or damaged. So to start, let's look at our hydrologic cycle or our water cycle again. So we've talked about streams, we've talked about coastlines. So here we are talking about groundwater, which is the subsurface reservoir, or the water that is underneath the surface of the earth. So water can infiltrate and percolate down from the surface of the earth. Not all of it runs off into our oceans. Some can actually percolate downwards, and it enters our water table, or enters the reservoir of our groundwater. So how does that happen? So in the hydrologic cycle, what happens to the water that falls to the surface of the earth? So we can have water either evaporating back into our atmosphere. It can run off into streams and into the ocean, or it can be trapped on land in terms of it's frozen, so it can snow. It can be trapped on land in terms of glaciers, so a lot of water is actually trapped on land because it's frozen. Or the last option is it can sink into the soil and infiltrate down into our groundwater table. So this is considered soil moisture. It can infiltrate deeper or further downwards into what we call the saturated zone. So this is where the open spaces between bits of rock or sediment are filled with water. So this is groundwater. So groundwater is not an underwater lake. A lot of people have that misconception that there's a lake underground that makes up our water table. That's not it at all. It's actually that all of the space in between the different pieces of sediment and rock are filled with water. So that water is it's infiltrated downward from the surface, and it's filled in all of that open space. That is what we call our groundwater. And then the top of that zone, so the top of what we call the saturated zone, where that groundwater exists, we call the water table. So the water table is the top of our groundwater. So groundwater can flow underground. So it's not just stuck in that location. It does actually move. Eventually, it will return to the surface over time, either by springs or streams, even wells. But the groundwater, it's not it's not underground forever. It does actually flow. It does move. So what is our groundwater reservoir? Where we have all of this water, it's all of these open spaces between the sediment or the rock that's underground. So two really, really important components of that are what we call porosity and permeability. So porosity is the total open space. So in terms of volume, how much open space is there that can be filled with water? It could also be filled with air. It could be filled with other things. But in terms of groundwater, how much space is there to be filled with water? So how much can this area of rock actually, how much water can it hold? Now, our primary porosity is the open space right after the formation or deposition of sediment or rock. So this is where the grains don't fit properly. There aren't, the crystals haven't grown to fill all the space, and the open spaces haven't been filled with other sediment or what we call cement. So there's still a lot of open space because this area or this rock is freshly deposited, the sediment's freshly deposited, that's freshly formed. So there's still a lot of open space. It hasn't been filled up by other things yet. That's what we call primary porosity. There's also secondary porosity, which is where there is space created within a rock after it was formed, after deposition. So this would be due to some type of weathering. So either physical or chemical weathering. This is going to create additional porosity because something has been weathered away. So there can be both types, primary and then also secondary. Primary is the porosity that was there at time of deposition. Secondary is something that is formed later due to either chemical or physical weathering. So porosity, here is a little cartoon to show you. Here we have our grains of sand in the darker gray, or in all of the gray. There's some cement in the tan color, the beige, and then the water is in blue. So this shows you the space that is able to be filled by water. So here, this is fairly low porosity in this cartoon here. All of this water that can fill in the space. This would be groundwater. So the other thing to think about, not just the volume of water that can be held, but how that water is able to move through the material. So that is what we call permeability. So we're not looking at, with permeability, we're not looking at the amount of space, but we're looking at how those spaces can connect. So for the water to be, for the rock to be permeable, water must be able to pass through it, meaning there must be passageways or cracks through different grains to allow water to move through. So high permeability would be a permeable material. This is where water can flow very easily. Low permeability or impermeable is something that water cannot flow through. So high versus low permeability really depends on the number of passageways, the size of the passageways, and then what the passageways look like in terms of, are they straight lines where it's very easy to flow, or are they very curved where it's going to take longer for that water to flow? So if you have a large number of passageways, the passageways are very large and they're totally straight, you're going to have a very high permeability. It's going to be very easy for that water to pass through. So here's an example of a higher permeability. So here you can see the porosity is very large. There's a lot of water here, all this blue. But the permeability is also fairly large, or fairly high, I should say, because the water can actually pass through around these grains. Whereas, let me go back, we have a very, very low permeability because this water cannot move through. It's just pockets filled with water, but they can't actually move through this material. So I mentioned our water table at the beginning. So now that we know how water moves or potentially can move through a material, you can think about our water table. So the water table really is the depth or the level or the divide between unsaturated and saturated. So unsaturated being it is not filled with water, saturated being all of the open spaces are filled with water. So the water table is that in-between layer, right where we move from the saturated area to the unsaturated area. So as water infiltrates downwards, it's going to infiltrate all the way down to the saturated area. So you're always going to have the unsaturated area above. That's just due to gravity. So water, as it falls, let's say with some rain here in this forest, the water is going to infiltrate all the way down until it reaches the water table. So above the water table, there's still pore space. So there's still this similar porosity as you're going to find below, but at this time it's filled with air. So there's not enough water to fill all the way up to the surface in this cartoon here. So this rock here, this soil, it still has permeability and porosity, but there's not enough water to fill it up completely, so it's filled with air. Below the water table, that's where we have all the pores are filled with water. So the depth of the water table, so where do we actually find this water table? Because it can actually move up and it can move down. It's really due to the elevation of your surface, the climate. So are we talking about a desert? Are we talking about a rainforest? And then also the seasons. So you can have a dry season and a wet season. So you might see your water table changing in the wet season versus in the dry season. And then the similar things can happen for yearly cycles. So a location can have a particularly dry year or a particularly wet year. That's going to change the location of the water table as well. So when there's more rain, when it's a wet year, a wet season, we're talking about a climate that gets a lot of rain, your water table is going to move up because there's going to be more and more and more water that's going to fill these pore spaces. So as more water is added, the more and more of the unsaturated zone is going to become saturated. So the water table, the divide between the two, is going to move up because we're going to have more water. If we're in a dry location, a dry year, a dry season, the water table is going to move down because there will be less water in our groundwater reservoir. So that is shown again here in this cartoon. So the depth of that water table, it can change pretty drastically, seasonally, year to year, and then definitely across the globe depending on the climate. So here we have a high water table. So let's say this is the wet season or a really wet year. So here we have a little dip in the surface of the earth. So the water table is so high that this is a river running. So here's the cow. He's happy. He's drinking his water. And it's raining. So we're going to keep that water table very close to the surface. However, let's say there's a big drought the next year. That water table is going to lower because there will be no more water replenishing it. It's so low that the stream dries out. These roots of this tree are no longer getting water. Really dismal here, but the cow died and is still there. Maybe it'll become a fossil. And so the water table is so low that there's no water in this stream at all. So where we have lakes, streams, wetlands, that's where we have the water table above the ground level. So the water table is above the ground level here, above the height of the surface, meaning that this stream is completely filled in. When that water table sinks below, that's when we have the stream drying out. The water table is not flat. So in these past figures, we've seen it as flat, but it is not. It generally follows the surface of the earth, so it sort of follows Earth's topography for the most part. Let's say here we have sea level on the bottom. The blue line is showing us the water table, and this black line with the beige beneath it is the surface of the earth. So where we have a higher topography on Earth, you're going to have a higher water table. Where we have lower topography, you're going to have a lower water table. It follows almost a less extreme version of our topography. So where we have high topography, we have high water table, but it's not going to be quite as high. Where we have low topography, we have low water table, but it's not going to be quite as low. So it's almost a simplified version of our topography. And that's because you have water falling all over the surface of the earth. So here you have rain falling here, you have rain falling here. The water isn't going to percolate at different rates. So it generally is going to percolate at the same rate. So you're going to see a mimic of the topography when you're looking at the height of the water table. So the next thing to talk about are aquifers versus aquatards. So this is what we call the different layers of rock. So an aquifer would be a layer where the sediment has high permeability and high porosity, meaning water can flow very easily through. So an aquifer is a layer of rock or a layer of sediment that has a large amount of water in it, and that water can move pretty freely. An aquatard is the opposite. So this is going to be rock or sediment that has very low permeability as well as low porosity. So the water is going to be very, very slow, if anything. So it can also be almost completely impermeable, where there's going to be no water. So here we're showing, in this picture, we have our water table here in the blue dashed line. Here we have an aquifer. We call it an unconfined aquifer because you could reach it from the surface. This is an area that has high permeability and high porosity, so there's quite a bit of water in the grains there. Here we have an aquatard, so low permeability, low porosity, there's no water there, no water's moving through this layer of the earth. Beneath that, we have another layer that is an aquifer, so another layer that has high porosity and high permeability, but we would call this a confined aquifer because it can't reach the surface because this aquatard is in between. So with groundwater, I talked about how the water table can change. So it can change in height. We call this recharge and discharge. So recharge is when we replenish groundwater. So this is due to rainfall or snow melting and then infiltrating downwards. And then we also have discharge. So discharge is where the groundwater emerges or comes up from the water table to the surface of the earth. So this is where we have streams, lakes, springs, sometimes the ocean. So here you'll see there's recharge where we have rain falling. So that water is going to infiltrate downward into our groundwater. So down through the water table, that is recharge. And then we have discharge, which is where the water from this water table is actually moving towards the lower elevation location and filling in this stream. So our water table is beneath the surface of the earth here on this hill. So we have recharge when water falls. The water table is above the surface of the earth here in this stream valley. So the water from the water table is actually, the water from the groundwater is going to fill in this stream. So here's another figure of that. Here we have recharge where it's raining, where our water table is below the surface of the earth. So it's raining and that water is going to infiltrate downward. Well, not all of it. Some of the water will infiltrate downward into our water table. That water is then able to move because this is a nice aquifer layer here, high porosity, high permeability, shown by the blue in the cartoon. So the water is able to move downwards towards this lower elevation surface of our water table as well, and fill in this stream. So we have two streams here that are being recharged and recharged by the rain, and then the water table is discharging into the stream. So the time scale of this recharge and discharge is a little bit trickier. So it's very variable. So for recharge and discharge, it depends where you're looking. So it really depends on the flow path of the water, the porosity of the rock, and then the depth of the water table that you're looking at. So, for example, here we have an area of recharge where our water table is beneath the surface of the earth. So the rain that falls here, some of it will run off, some of it will be taken up by these plants, some of it will percolate downwards into our water table. Here we have an area of discharge where our water table is right at or beneath above the surface of the earth. So this water from our water table is actually going to fill in this stream. Now, the time for that recharge and discharge is what depends quite a bit on the type of rock and also the depth. So for water, it percolates downwards and is right at the water table line, right at the surface of the water table. To reach this stream, it might take just a few days. So if it rains, in a few days, you're going to see some of that water down in the stream. However, if that water flows straight downwards, so instead of being very close to our stream where the water is going to travel very quickly to our stream, if our water flows straight downwards through this groundwater system, it's going to take a very, very, very long time. For example, here, this flow line that we're looking at shows it's going to take about a millennia for the water to flow all the way down in this aquifer and then back up to this stream. So it depends on the path of the flow, so the direction that the water takes, the type of rock, and then also the depth that you're looking at. So the deeper that the water goes, the longer it's going to take to to discharge back up to the surface. So here is a little comic of these guys. They were just off by a little bit trying to get to the aquifer layer to this groundwater. If they had moved just a bit, they would have been able to find their groundwater.